Hi, this is Jeff from Command Performance AV. Today we're going to be doing something a little different than our usual unboxing. We had a great opportunity to go visit Nick Doshi Audio's facility in Charlottesville, Virginia. Nick Doshi Audio builds some of the best high-end tube electronics in the industry. A lot of the insiders know his name, but he's really this hidden gem of brilliant designer, comes from the studio world, brings that expertise into building consumer electronics, and we just love his products here. And we had an opportunity to go down to Charlottesville to visit Nick and look how he puts his stuff together, the care, the quality that really matters for him to build top-of-the-line tube gear that really, anyone who really has ever heard it, beats their expectations. So what we're going to do now is step back and go down to visit Nick in Charlottesville and learn a little bit more about his development process.
Fabrication shop at Doshi Audio, and one of the things I wanted to demonstrate was how we actually set our moving coil boards up so that we can adjust them for the maximum amount of common mode noise rejection. The way to do it is to feed the moving coil board with an unregulated power supply. So this has the maximum amount of ripple, 60 cycle and 120 cycle noise, and then adjust the differential amplifier. I will sit down, if you pay attention to the spectrum analyzer, that's a very old and trusted piece of gear that I've owned for close to 30 years now, and it's a 3580. But one of the cool things about a 3580 is that it's entirely in the analog domain, so it's real time, and when you make adjustments you can see what's going on. So I'm going to adjust this and watch the 60 cycle peak, and you'll see that it starts to come down every sweep of the analyzer, and that's me adjusting the resistor between the tails of the differential amplifier. And those of you with sharp eyes will notice that my reference setting is at -40, which means that the -80 peak on the spectrum analyzer, which is right here, is actually at 120 dB below 0 dB. And so that's a moving coil amplifier that can be trusted to deliver extremely low noise performance. And in a Doshi preamplifier with regulated power supplies, all of those would be automatically attenuated anyway. So that's the process by which we adjust every single moving coil preamplifier channel that's in our phono stage. Hopefully that gave you a little bit of insight into the amount of care that goes into building each Doshi unit. So those transistors have to be matched. Okay, so those 4 JFET transistors have to be matched. That is a V-shaped bulk foil trim resistor. So that piece just by itself is close to $25 per. Right. What the resistors you're seeing are TKD out of Japan. They're custom made for us. Well, these values are not custom, but the resistors are custom ordered. The transformer that you're seeing here is actually a step-down transformer. The head amplifier has a lot of gain, about close to 30 dB of gain, and so it allows us to step the signal down. The reason we do that is that the tube topology of the phono stage is single-ended. This is a differential amplifier. The transformer allows us to go from differential or balanced to single-ended while also completely isolating the moving coil amplifier from the tube section. So all of the power supply noise, etc., that goes on with a high voltage tube amplifier has no chance of ever being interfered with as far as the moving coil section is concerned. So that's the dual benefit of having a step-down transformer.
Tell us about the caps you're using there.
So yeah, the caps are actually quite special. These are made for us custom by Clarity Cap, Sharcroft ICW in the UK. This is their Purity range, and a cool thing about the Purity capacitor is that ICW Clarity went through a comprehensive design process for the first generation of this capacitor. The first generation was called MR, which was stood for minimum resonance. What they found was that capacitors, because they're ionized plates that are stacked up against each other, are piezoelectric. Every time you put a signal across them, you change the potential difference across the plates of a capacitor, and you cause the force to push and pull the plates together and apart based on your music signal. Well, that can add noise to the signal. That can add intermodulation, distortion, all sorts of things. And what ICW Clarity did was to encapsulate the capacitor in a PVC tube, which removed external vibrational sources, but also gave the capacitor a very rigid, fixed enclosure with which to reduce its own internal resonances, right? The Purity series is their latest series, the series wound PUR. And what they've done is the end caps of the capacitors, you can see it slightly better here, is that this is actually a copper matrix.
It's beautiful.
Instead of sintered zinc, which is how capacitors are usually built. Tin and zinc are the materials used to form the ends of capacitors. They use a copper matrix. It reduces the amount of crystal structures in that matrix by a factor of 10 to the third, so 1,000. And so you have much less diode sort of activity in the end caps of a capacitor, etc. So we're very happy to use the PUR series of caps for all of the Doshi products. We think that cost is never an object for us, but cost not being an object, this is the most reliable device, and also sounds fantastic. So we're happy to feature Clarity caps from.
What do you got over here? What are you working on over here? Look at all this beautiful stuff. Huh?
These are Christmas presents.
Yeah.
These are end play. These are rear panels. The ones with two speakers are obviously monoblock amplifier that we're building, and the one with the four is a stereo amp that's being built on custom.
Who's binding posts to those?
Those are Cardis binding posts. We are happy to partner with the perennially pleasant folks from Cardis, and we think that they make some excellent products, and we're happy to use them. They have never let us down. So
is that some sort of filtering after the inlet, power inlet?
Yeah, it's nice of you to point that out, Jeff, because we're kind of, one of the things that my broadcast engineering, in radio and television background brings to my priorities as far as the audio industry, as far as an audio company and an audio professional go, is that you have to design for reliability as your priority. If your customer is not able to have any sense of confidence that this stuff is going to work and he's going to be able to enjoy it for a long period of time, that does play psychologically with the ownership experience, etc. So we keep that in mind in everything that we do. The custom transformers that we have built for us are designed with reliability, the parts that we use are designed with reliability. One of them is the power inlet. Now, this is a power inlet. Well, what's so special about a power inlet, you ask, Nick? Well, this one is made by a company called Schroeder in Germany. And again, the eagle-eyed amongst you will notice that this particular unit has a couple of features which I find very, very attractive. One is that it is fused on both the live and the neutral. One of the pieces of advice I like to give my audio friends is, as far as possible, try to use balanced power in your audio systems, because it allows the primary side of your power transformer to cancel all of your power line noise. Well, if you're using balanced power, that means you've got 60 volts on both legs of your power. And as a safety issue, you want to have both legs, the live leg and the neutral leg, fused. So this Schroeder AC inlet has fuses on both the live and neutral legs. The other kind of cool thing it does is that it's been designed for audio, and it has a choke in the ground. So any noise that's riding on your ground is not going to make it inside your chassis. So, added advantage, definitely not as cheap as all the other power inlets that are out there and available to use, but the dual fuses gives me peace of mind, and the ground and the choke in the ground means that you can have a 40 foot length of power cable running around, etc. You can have your Wi-Fi router sitting next to your amps and all those things, and the chances that this will filter it out increase because it's been designed that way. So that's the suggestion by Jeff that I talk about power inlets.
Well, it seems to...
For those of you who are still awake.
Well, currently, there's such growing area of ground cleaning that's really hot, but you were way ahead of it and building it into the amplifier versus an external device.
Correct.
Now, there's something to be said for grounding everything together, but, most people just ignore it in the design altogether.
And that's the, you touch upon a basic philosophy of mine, which is, how do you build something that is going to be applicable and usable in the largest amount of situations? How do you build a preamplifier that has enough flexibility to interface with, any type of cabling, any type of cartridge, any type of source, that kind of stuff? And how do you build an amplifier that can drive, a whole bunch of different type of loudspeaker, etc.? So this kind of follows that, in that, how do you get it together so that when you ship a product to a customer, or you as a dealer take a product to your customer, the chances of it working really well are really high. And so it's often boils down to small details like that, where you could be in an apartment in New York City and for sure the ground is completely contaminated, right?
Right.
And the chances that this thing will filter out the noise by 6, 7, 8 dB are pretty high, and the customer ends up with a better result. So,
But it's less things for me to sell as an accessory. So there are trade-offs. Anyways, I digress.
if you drill into here in just the right spot, no. But I'm sure a lot of German engineers will be really unhappy with that. So having said that, we do pride ourselves in building gear that takes reliability into account, that takes the availability of the best of breed parts from all over the world, and that's how we put our products together. We have all stainless steel non-magnetic chassis that are built in Southern Virginia. We have capacitors that are built in the United Kingdom, or Great Britain as they would want to call it. We have Teflon machined thin tube sockets that are built in Hong Kong. So we try to pull all this together. We have resistors that are built from TKD in Japan, and you want to see my resistor box? There's our
We can't resist.
Yeah, you can't resist seeing my resistor box. But these are TKD resistors from Japan.
Wow.
We love our folks from TKD. So
Do the
that's,
green bins sound better than the blue bins?
it depends. For jazz, I prefer the blue bin.
I understand.
But for rock and roll, you gotta have green.
Gotta go green.
Yeah, so, and I'll show you our custom wire that we. So, why does a small company like Doshi Audio invest thousands of dollars into cable, into wire that connects the power supply and the preamplifier together? It has to do with, the fact that we're lunatics, firstly, and secondly, that, wire can be a source of noise in the way that it picks up noise that's in the surroundings. Or self-generated noise in some cases as well, especially when you have very, very small signals like moving coil, cartridge outputs, etc. Any small, pickup of noise can affect your output signal. So we decided that we were going to have our umbilical wire custom made for us. This is made in the United States. It's made at New England Wire Technologies up in New Hampshire. And as you can see, it's a pretty complex, convoluted production. It consists of 9 conductors, all 14 gauge, Teflon wrap with internal fiber damping in the center of the conductor. The conductor pairs are then wrapped in a spiral foil shield with a copper drain. They're also separated with polyfill for additional damping control. This assembly is then wrapped in Teflon tape, which is then covered with a carbon doped poly for additional damping. And then the whole assembly is then covered with a tin copper braid shield. So you have 4 levels of shielding. What this allows you to do is use the outer shield as the safety ground between the preamplifier unit and the power supply. This is just in case you have a failure of a tube, etc., inside the unit, and the high voltage gets into contact with the chassis. You know that you have a ground path so that it can be safely conducted away. The other advantage of having these shields and these grounds is that at the power supply end, we tie all of the grounds together. This way, any coupled noise, any inductively coupled noise, anything that the power supply cable, the umbilical, is going through a high current AC cord in the vicinity of, etc., is also attenuated. So an expensive solution, but we feel like it adds sort of the cherry to the cake and gives our customers, yet another thing to point to as okay, we did go the extra mile, and we thought of everything we could possibly do to make a good product. So.